Hey guys, welcome back to another video of USACO walkthroughs. Today we're going to go through the problem, why did the cows cross the road 3 from the 2017 February bronze contest. And yeah, let's just jump right into it. So starting off, Farmer John in his old age has unfortunately become increasingly grumpy and paranoid, forgetting the extent to which bovine diversity helped his farm truly flourish over the years. He has recently decided to build a huge fence around the farm, discouraging cows from neighboring farms from visiting, and completely prohibiting entry from a handful of neighboring farms. The cows are quite upset by this state of affairs, not only since they can no longer visit their friends, but since it has caused them to cancel participation in the International Milking Olympiad. Interesting. An event to which they look forward all year. Neighboring cows that still have the ability to enter Farmer John's property find the process has become more arduous, as they can only enter through a single gate where each cow is subject to intense questioning, often causing the cows to queue up in a long line. Okay, so for each of the N cows visiting the farm, you are told the time she arrives at the gate and the duration of the time required for her to answer her entry questions. Only one cow can be undergoing questioning at any given time, so if many cows arrive near the same time, they will likely need to wait in line to be processed one by one. For example, if a cow arrives at time 5 and answers questions for 7 units of time, another cow arriving at time 8 will need to wait until time 12 to start answering questions. Please determine the earliest possible time by which all cows are able to enter the farm. So what it's basically saying is, please determine the earliest possible time that all cows in the line are finished questioning and answering and had entered the farm. So basically we're finding out when the last cow enters the farm after the questioning. So let's see the input format. The first line of input contains n, a positive integer at most 100. So there's only 100, like the maximum possible cows in the line is only 100. Each of the next n lines describe one cow, giving the time it arrives and the time it requires for questioning. Each of these numbers are positive integers at most 1 million. So every one of these numbers can be 1 million. And it asks, please determine the minimum possible. We already know that. So let's look at the sample input, right? So we have 3, 2, 8, 3, and 5, 7. So the sample output is 15. So let's see how they got that. So we start at cow 2, right? And starts at cow 2 and it's quickly processed with a wait time of 1. So it is not time 3. But as you can see, there's no other cow in the line that needs to be processed at time 3. So then we have to wait until time 5, where a cow comes and begins processing. But here's a long wait time, a wait time of 7. So the second cow has to arrive at 8, which is, I think it was an example here, and waits until time 12 to start answering questions, which is 5 plus 7. So the second cow arrived at 5 and began processing for 7 units of time until time 12. But since the third cow, or the second cow in input-wise, arrived at time 8, it has to wait until time 12 to start answering questions. So finishing at 12 plus 3, because it took 3 minutes for the final cow to get processed, to 15. So how do we do this? Well, if you want to think about it for yourself, I can give you guys a bit of time. You can stop the video and you can figure it out yourself, or I can just explain it to you and you keep on watching. So let's go to a whiteboard. Let me get my pen out. Okay, let's go. So the input was 3. Let me think. 2, 1, 8, 3, and 5, 7. So our method of thinking here is process the first cow as soon as possible. Actually, no, not just the first cow, the next cow as soon as possible. Wait, you guys can't see that. ASAP, right? So after we process the next cow, we have to find the wait time. Now find the next available time. Next available time. And after we find the next available time, we can process the next cow. So, starting from the lowest one, right? It's 2, is already the first one, conveniently. It's the next cow in this list, so let's just process this one, right? Start at 2 plus 1, right? So now the next available time is 3. Next available time that we stated before. Wait, you guys weren't able to see this, so let me just re-explain. Start at 2 plus 1, that's equal to 3. So the next available time is 3, right? But there's no other cow right now, so we can't process the next cow. How are we supposed to process the next cow? There's no cow here. But then we see, oh, there's a 5 cow over here. So we process him then. So instead of 3, it becomes 5. And we add 7 and equal to 12. So 12 is our next available time, right? But we already see that cow, the final cow, has already arrived. So we can immediately process him with plus 3. And that's equal to 15. So there are 2 very important things. First, we need to sort the input. We need to sort the line so that we can need to sort by the first index so that we can figure out which cow is next, which cow do we need to process as soon as possible. The next thing is we need to check if after we process the cow, we have to when do we process the next cow? Because as you noticed, the next available time was 12, but the cow already arrived, so we don't need to wait for the next cow. But in the first time we did this, where you went 2 plus 1 equals 3, no cows arrived at 3, so we have to wait for the cow that enters at time unit 5, so we can process him. Okay, so now let's get to the code. Okay guys, so now all you need to do is head to your IDE or your coding platform, whatever you code on, and we're going to do some coding. Okay, so let's start with input. So USACO is a bit weird, okay? So since this is a 2017 problem, input was a bit different from how it is now in 2026. So easy way to do this is just to import system and do system.standin equal open cowq.in. So this is just setting up the input. But you don't need to do this now in the new competitions because they have changed the ways you do input now. Okay, now we can freely just do using the input function instead of doing file input, which is way easier. It's a great decision by USACO. So let's just take in the input, right? So we can start with n, which was the first line. Right, this is the amount of cows in the line, and now we can have a variable called cows and make it an empty list. Since now we're going to add all the cows into this list so we can process them later. But every cow just doesn't come with the time it comes with. It also comes with how long it takes to process that cow. So how do we put both in? Well, we first need to make this for loop. Then we need to make then we need to add both the time and the value, or the amount of time it takes to process this cow. And let's just put it as a list, right? We're just processing the cow as a list. And then now we add this cow as a list, time, and value. And now we just have a list of every single cow that has come in the line. But the specific thing I said earlier was that we had to sort the list. So, but then you notice, how do you sort a list of lists? But a cool thing you should know about Python is that it's very easy to do stuff, right? Like, for example, a default of the sort function, cows.sort, is that even if it's a list of lists, it's still sort by the first index of every list. So it doesn't matter what the second index is, as long as the first index is smaller, then that would go in front of her. So yeah, it's just really simple and really good by Python. Because Python is really easy to pass bronze with because it's just like the functions and the simplicity is just so good. Okay, so by doing cows.sort, we sorted all the lists inside the lists by the first index, so it's basically sorted by the time they come. Okay, now let's just do some setup. So first we have these two. We have two variables that we need to initialize: current time and index. Okay, you'll see why we need to use these later. Okay, so personally, I would like to use a while loop since while loops are kind of simple and they know exactly when they break, or you can control it. So we need to process the current cow, right? And the current cow is always going to be the cow that we are processing, so we just do cow's index. So let me explain to you what index is. Index is the current cow we're working on, the current cow we're processing. And we know that's the next cow because whenever we're done processing a cow, we add 1 to index, and that's the very next cow that arrived. So now we can just do some simulation, and yeah. So let's write an if statement to see if the cow has arrived, since now we are comparing it to current time. So let me explain current time. Current time is the time we are at currently. So right now we're at 0 seconds, or 0 units in time, and current cow 0 is the time the cow arrives. So we check if the current time of the cow coming is greater or equal to the current times, which means that is the cow here or not? Is the cow here, or is it going to come later? So if it is, right, then we do current time is equal to current cow plus current cow 1. So current cow 0 plus current cow 1. So let's see here. Current time is our current time. It's currently at 0, but now it's becoming current cow 0 plus current cow 1. So the time it came plus the time it takes to be processed. And you see here that in my explanation, I talked about a variable called next available time. Well, next available time is actually not even needed, considering how current time, after we add the time it's processed, is just automatically the next available time. This is automatically the next available time since we already added the current cow and the time it takes to be processed. So every time it loops through, it's always going to be the next available time or the current time, because there's still a possibility that we have to wait for a next cow. So it doesn't really mean that we process the next cow immediately. So else. So there's only one other case other than greater or equal to current time. It's less than or equal to current time. Less than current time, right? And that means that the cow has already arrived. It's just waiting to be processed because the wait time is so long. So if that happens, then we can just set current time equal to current time plus current cow 1, because the next available time is greater than the time the cow came to arrive. So we can just add the time it takes to process, and that'll be it. But I forgot one specific thing. We forgot to add index. Index plus equal 1. Because if we just process the cow, the index stays the same. So we just keep on processing the same cow. That's not going to work. So we have to add 1 to index. Okay, so now we need to check if all the cows are processed, where we can break outside of the while loop. So let's do if index is equal to n. So if we processed n cows, then we print the current time. And we also have to do a bit of output weirdness because USACO had to make some systems that out-right instead of standard input, standard output. And we also have to break the for loop since we already finished processing all the cows. So this is the code that we have. If you guys want to test it out, let's just test it out real quick. So let's comment all this out because we don't have a file. Let's actually just Control X this, cut this out real quick, and let's just test this. Okay. Interesting. Okay, now let's enter the sample input just as a test. So there's 3 cows. First cow was 2, 1. Second cow was 8, 3. Not sorted in this case. And the final cow was 5 and 7. So as you can see, we output 15. That is the correct answer. So let's try and input it. So let's first undo all of this. And now it's ready to be inputted. Let's just run it so we can save it real quick. And yeah, let's just try it out. Okay, we are back on the USACO website, ready to test this problem. I had a bit of an error, but I just fixed it. It was just I just typed a random character somewhere in the code, but I fixed that real quick. So yeah, I found my file. I clicked Python. We're ready to submit. Let's submit. Okay, grading in progress. Okay, 3 test cases. Oh, we just got all of them. Yeah, 10 test case passed. 100% guarantee. I just gave you the full solution to this problem. Thank you guys for watching. Make sure to like and subscribe, and see you next time through the next USACO walkthrough. But don't forget that if you want me to go over a specific bronze problem or silver problem or gold problem, just ask in the comments, and let's see if I can use it as a video.